Good morning, my name is John Cook and I am from the University of Iowa. Today I will present our research titled Inferring Tracker-Advertiser Relationships in the Online Advertising Ecosystem Using Header Bidding. We formulate the basis of our research into two objectives. First, by understanding how much advertisers are willing to pay to reach users, we uncover new insights into advertiser bidding behavior. For this, we exploit a new programmatic bidding paradigm known as header bidding. Second, we introduce a novel technique named Kashifa for uncovering data sharing relationships between advertisers and trackers. We operationalize our insights by training interpretable machine learning models that use the presence of trackers as features in order to predict the bidding behavior of an advertiser. By analyzing these models, we are able to infer tracker and advertiser data sharing irrespective of whether it occurs at the client or server side. Finally, we identify several data sharing relationships that are validated externally but are not detected by client-side cookie syncing. We motivate this research problem by examining the importance and challenges for understanding data sharing in the advertising and tracking ecosystem. First, data sharing is crucial for ad campaign effectiveness, and for this reason, data sharing relationships are prevalent within the advertising ecosystem. Second, developing an understanding of data sharing relationships, both client-side and server-side, is important for enhancing user privacy and improving regulatory compliance, such as GDPR and CCPA. We focus on two challenges for measuring data sharing relationships. First, we note that client-side measurements are insufficient for detecting these data sharing relationships. This is due to brittle detection heuristics that break under non-standard implementations or when obfuscation is employed. Most importantly, server-side data sharing is not directly visible from the client, and the state-of-the-art for detecting server-side relationships uses manual techniques that do not scale easily and are prone to human error. Online advertising relies on trackers in order to display customized ads based upon user browsing history. This diagram shows a simplified interaction between website publishers, trackers, and advertisers. As a user navigates from one site to the next, their browsing history is relayed from online trackers to online advertisers. The advertising ecosystem relies on trackers in order to present customized ads based upon perceived user interest. As CNN.com loads, an online auction occurs in the background where advertisers bid on available page space. Following the auction, the winning bidder's ad is displayed and the publisher's compensated payment. It's noteworthy that publisher ad revenue in the US surpassed $100 billion annually in 2019. Prior work in real-time bidding, or RTB, leveraged winning price notifications, which only expose the winning bids at the client side. We address two major limitations for measuring user value in RTB. First, RTB winning bids are not the actual price paid by the advertiser, but rather slightly higher than the second highest bid. In contrast, header bidding uses first price auctions, where the price paid is typically based on the highest bid value. Therefore, we are able to draw conclusions about what an advertiser actually pays to reach users. Most importantly, winning bid notifications do not include information about other bidders. By utilizing header bidding, all bids are available at the client in plain text. This allows us to draw new insights previous measurement studies could not by understanding how much an advertiser is willing to pay. These two limitations are illustrated in the following diagram. It is important to note that reducing winning bid price to the second highest bid can negatively impact publisher revenue. As mentioned previously, information from other bidders are not available at the client. And by using header bidding, we can answer both what an advertiser actually pays, but more importantly, what they are willing to pay. To understand how much advertisers are willing to bid for different users, we design web personas based upon Alexa categories. To train each persona, we conducted controlled web crawls using a lightly modified version of OpenWPM. Using a fresh browser state, we visited 50 URLs from each category and stored the resulting cookies. We also trained 16 additional intent personas by first navigating to product pages, reserving an item on each page, and then proceeding to train on each Alexa category as we previously mentioned. Finally, we design a control profile to represent a browser with no associated history. On the bottom, we include a trained persona for both intent and no intent for the sports category. Using our trained personas, we then visit header bidding enabled websites and record bidding responses for each web persona. In the following tables, we show results for average bid values and intent to no intent ratios for each category. We first note that the health category attracts significantly higher bids for both intent and no intent personas. Secondly, web personas such as home and games were universally unfavored by advertisers, and we conclude that a user's web persona impacts the bids placed by an advertiser. When comparing intent and no intent personas, we see large increases. For example, sports, which received the lowest bids among all advertisers in no intent, increased by 2.43 times when combined with intent history. We conclude that perceived intent impacts advertiser bidding behavior. We now turn to our second research objective and discuss data sharing relationships among trackers and advertisers. To motivate their problem, we pose the following questions in order to understand tracker influence on advertiser bidding behavior. First, we wanted to understand whether or not tracker presence is a predictor for advertiser bids. And secondly, which trackers influence behaviors of advertisers the most. Our setup uses an intuitive notion that an ad campaign's effectiveness is highly dependent on the quality of information it receives from trackers. To ascertain how trackers impact advertiser bidding behavior, we conducted controlled web experiments by monitoring header bidding bids in response to selective tracker blocking. To uncover server-side sharing, prior work used detection of retargeting events between ad exchanges and other sites. While retargeting is a sufficient condition for server-side data sharing, it is not a necessary one. By observing all bids on behalf of advertisers participating in header bidding, we are able to monitor bidder response as browsing history and tracker information is varied. Secondly, prior work is limited due to processes which require manual effort that do not easily scale and are prone to human error. We use an interpretable machine learning model that are separately trained for each advertiser. We argue that a model that predicts advertiser bids from tracker presence as input features also uncovers data sharing relationships between advertisers and trackers. In the following diagram, we show our experimental setup for inferring tracker-advertiser relationships. To begin, we modify our earlier crawl sequence by creating 10,000 personas which visited an average of 5 categorical sites, followed by 1 header bidding site. Secondly, during crawling, we apply selective blocking for all trackers for a specific organization. We then train machine learning models using trackers as input features in order to predict advertiser bids. We argue that if a machine learning model, given edge 1 in the figure above, is able to accurately predict edge 3, then it must have automatically inferred the presence or absence of an edge. We finally leverage the interpretability of trained machine learning models to determine which features, in other words, trackers, were most influential in predicting the values of bids placed by advertisers. We show the performance of each of our models for the top 5 header bidding advertisers within our dataset. Our trained machine learning models can predict bids by different bidders with reasonable accuracy. Specifically, our model's accuracy ranges from 75% to 83%. It is noteworthy that our models provide similar accuracy when compared against previous work in RTB. Secondly, to assess influence, we rank trackers according to information gain in each advertiser model and assess the top 3 trackers. Specifically, we validate our ranking list by comparing sources of known advertiser relationships, namely through assessing cookie syncing in external databases. Most importantly, we find that 11 out of 15 potential server-side tracker advertiser relationships can be validated externally, but not through cookie syncing. Finally, we acknowledge simplifying assumptions and limitations that may impact the completeness and correctness of our method. We made a simplifying assumption only to include bidder relationships within the top 20 tracker list, and as a result are not able to make inferences about relationships beyond the top 20 trackers. We note that prior work has demonstrated extreme skewness of tracker coverage, and we argue that the overwhelming majority of tracker-bidder relationships are captured within our top 20 list. Our approach is unable to determine whether a tracker-advertiser relationship is direct or indirect. However, so as long as trackers impact bids, our approach is able to infer tracker-advertiser relationships. To mitigate the imperfect accuracy of our model, we limit our assessment of tracker influence to only the top 3 trackers of each model. Finally, our model may fail to detect tracker-to-tracker data sharing, and we mitigate this by analyzing trackers at the organization level. Today I've discussed how our work leverages header bidding to gain insights into advertiser bidding behavior. Our work advances the field along 2 main avenues. First, our work provides more nuanced insights into the bidding behavior of online advertisers. Second, we are able to infer data sharing relationships between advertisers and trackers, irrespective of whether they are occurring at the client side or the server side. This concludes my presentation. I want to thank you all for listening, and I look very forward to your questions.